before the word mathematics existed, before anyone wrote down a number, before there was a single written formula, a single chalkboard, a single school. People were building things that required exact calculations, perfect alignment, and an understanding of the sky that would take modern scientists years to reverse engineer. And they did it with stone, bone, antler, rope, and their own eyes. No calculators, no computers, no formalized geometry. Just precision so sharp it still makes researchers put down their coffee and stare. This is not a mystery. This is documented, measured, peer-reviewed, and published in places like the Cambridge Archaeological Journal, the journal Nature, and Antiquity. These were real builders, real calculations, and real structures that are still standing thousands of years later. And what they left behind forces us to completely rethink what human intelligence looked like before writing, before cities, before everything we assume was needed for people to think mathematically. If you value deep-cut prehistoric history backed by real research and real measurements, subscribe right now. It is the best way to support work like this. And drop a comment telling us what city you are hearing this from. We read every single one. This script is drawn from peer-reviewed research, including Hockley and Gopher's 2020 paper in the Cambridge Archaeological Journal on Göbekli Tepe, archaeoastronomer J. McKim Malville's 1998 findings published in Nature on Nabta Playa, Glenn Dash's 2017 paper in the Journal of Ancient Egyptian Architecture on pyramid alignment, and Bettina Schultz-Paulson's 2025 Neosea project findings published in Antiquity on the Karnak stones. These are real sources from real researchers. Now back to the builders. Let's go back 11,500 years to the Şanlıurfa province of southeastern Turkey, to a limestone ridge 900 meters above sea level. The year is roughly 9,500 BCE. Hunter-gatherers, people who have not yet invented farming, who do not yet have permanent homes, who have no written language, no metal tools, no wheels, are dragging limestone pillars that weigh between 10 and 20 tons up to the top of a hill. And they are placing them with exact geometric precision. The site is called Göbekli Tepe, which in Turkish means potbelly hill. It is a 15-meter high artificial hill covering 9 hectares, and it is the oldest known temple in human history. German archaeologist Klaus Schmidt recognized its significance in October 1994 after being guided to the site by a local farmer named Mahmut Yildiz, whose family owned the land. Schmidt had previously worked at a similar Neolithic site called Nevele Chori and immediately understood what the limestone slabs protruding from the soil meant. He began excavations in 1995, and what he found changed everything. The enclosures at Göbekli Tepe contain T-shaped pillars up to 5.5 meters high. 4 complete round structures have been fully excavated, ranging from 10 to 30 meters in diameter. Geophysical surveys show at least 16 more structures still buried, enclosing up to 8 pillars each, nearly 200 pillars total still underground. But here's where the mathematics begins. In May 2020, researchers Gil Hockley of the Israel Antiquities Authority and Professor Avi Gopher of Tel Aviv University published a study in the Cambridge Archaeological Journal. Using an algorithm based on standard deviation mapping, they discovered that 3 of the main circular structures at Göbekli Tepe, enclosures A, B, and C, were not built one at a time over generations. They were designed as a single unified project, laid out according to a coherent geometric pattern from the start. The largest of these enclosures is 20 meters in diameter. The people who built it were not farmers. They had no settled communities. And yet they pre-planned a complex building project requiring precise spatial geometry, coordinating the placement of 3 separate massive circular structures according to a master design that researchers in 2020 needed computer algorithms to fully decode. Think about that slowly. Schmidt estimated that moving the pillars alone required hundreds of people. Using Thor Heyerdahl's experiments with the Easter Island Moai as a reference point, a single pillar of similar size would have taken 20 people a full year to carve and 50 to 75 people a week to transport even 15 kilometers. One account of a megalith construction on the Indonesian island of Nias from 1917 documented 525 people working for 3 days to erect a single stone. At Göbekli Tepe, the builders were moving many more than one, and they were aligning them to a pre-planned geometric design. No writing, no formal geometry, just the precision in the stone itself. The Karnak stones in Brittany, northwestern France, do the same thing on a scale that becomes physically hard to comprehend when you stand among them. More than 3,000 prehistoric standing stones stretch across 10 kilometers of Atlantic coastline, from Karnak and La Trinité-sur-Mer to Erdeven. These are not scattered rocks. These are long, parallel rows of granite menhirs, thousands of them, arranged in carefully organized alignments across 40 hectares. The largest individual stones stand up to 4 meters high. The rows are so consistent in orientation that in 2025, researchers with the Neosea project, a French-Swedish collaboration led by archaeologist Bettina Schultz-Paulsen at the University of Gothenburg, published new findings in antiquity proving just how deliberate this was. Using nearly 50 radiocarbon samples, sediment analysis, charcoal analysis, and Bayesian statistical modeling, Schultz-Paulsen's team dated the Karnak alignments at a site called Le Plasker in Plowharnel. The results were stunning. The stone alignments were constructed between 4,600 and 4,300 BCE, making them among the earliest megalithic monuments in all of Europe. That is over 6,000 years ago. The team confirmed that the Bay of Morbihan is Europe's oldest known megalithic region, predating even the famous stone circles of the British Isles. The Neosea project also discovered that the stone lines were constructed alongside hearths and cooking pits, suggesting that the building of these precisely aligned rows was connected to communal fire-based activities, possibly ritual feasting while the stones went up. The Lemenek alignment alone, the most iconic section at Karnak, contains approximately 1,100 stones arranged in 11 parallel lines stretching over 1 kilometer. The stones begin smaller at one end and increase in height to roughly 4 meters at the western terminus. This is not an accident. The consistent north-northwest to south-southeast orientation across all construction periods, documented in the foundation pits even after the stones themselves were removed, tells researchers this direction was deliberate and symbolic, maintained over centuries. You're not looking at random piles. You're looking at a community that built a 10-kilometer geometric landscape without GPS, without written measurement, and without a single tool made of metal. Cold, precise, intentional. Now to Ireland, the Boyne Valley, County Meath. 50 kilometers north of Dublin, where the river loops through green farmland, a farming community built something in 3,200 BCE that would not be matched in engineering sophistication for a very long time. It is called Newgrange. It is older than Stonehenge by more than 1,000 years. It is older than the Great Pyramid of Giza by more than 600 years. Its original Irish name is Brú na Boine, the Mansion of the Boyne, and its most critical feature is something that should not be possible, given what we assume about the people who built it. Newgrange is a circular mound 85 meters in diameter, 13 meters high, covering about 1 acre of land. It weighs approximately 200,000 tons. A single stone-built passage, 19 meters long, leads into a cruciform central chamber. The corbelled roof above that chamber, stones stacked in overlapping layers that converge into a dome with no mortar, has remained completely watertight for over 5,000 years. Not one crack, not one leak. Archaeological excavations between 1962 and 1975, led by archaeologist Michael J. O'Kelly, confirmed construction around 3,200 BCE through radiocarbon dating. 97 massive curbstones ring the base. Some come from the Mourne Mountains and the Wicklow Mountains, transported significant distances by these Neolithic farmers. But O'Kelly noticed something. On December 21st, 1967, he became the first person in modern times to observe what happens inside Newgrange at the winter solstice. At 8:54 hours GMT, the top edge of the sun appeared above the local horizon. A narrow beam of light entered through a specially constructed opening above the passage entrance, called the roof box, and traveled 19 meters down the narrow passage until it filled the central chamber with a golden glow. The illumination lasted approximately 17 minutes. Then it was gone for another year. This was not an accident. The roof box is a precisely engineered opening, approximately 90 centimeters in height and 1 meter wide. It was designed to allow light to enter only during the winter solstice sunrise at this specific location, while the main entrance below remained in shadow. Research published in the journal Astronomy and Astrophysics confirmed the deliberate nature of the alignment. The alignment is within half a degree of the sun's disk. The height of the gap behind the roof box varies between 18 and 22 centimeters. As seen from the main chamber 18 meters away, this gap subtends an angle of roughly 38 minutes of arc, precisely framing the sun in the vertical direction. For this to work, the builders had to calculate the angle of sunrise on the winter solstice at this specific latitude 5,000 years in advance of the moment it would be witnessed. They had to know exactly where the sun would rise. They had to build the roof box at exactly the right height and angle before a single stone was placed over the top of it. And they got it right. Right enough that it still works today. Though due to the Earth's precession over 5,000 years, the beam now appears about 4 minutes after sunrise, rather than precisely at sunrise as it did in 3,200 BCE. For the winter solstice event, nearly 30,000 applications are submitted every year. In September, 60 names are drawn by local school children from Denore, Knockcommon, and Slane for the right to stand inside that chamber and watch the light return. That is what a correctly calculated 5,000-year-old astronomical observatory produces in 21st century demand. Now we are going to go somewhere most people have never heard of. 800 kilometers south of Cairo, 100 kilometers west of Abu Simbel, the Nubian Desert in southern Egypt. The year is approximately 4,800 BCE, in a region that, 10,000 years earlier, was a grassland fed by seasonal monsoons and dotted with natural lakes. Nomadic cattle herders built something, a stone circle, not large, only 4 meters in diameter, nothing like the scale of Karnak or Newgrange. But what this small circle does is extraordinary. It is called Nabta Playa, and it may be the oldest astronomical observatory on Earth. The site was first discovered in 1973 by anthropology professor Fred Wendorf of Southern Methodist University in Texas, who found pottery shards and artifacts sticking out of the desert sand. But the astronomical significance was not understood until Wendorf brought in archaeoastronomy expert J. McKim Malville, professor emeritus at the University of Colorado. Malville's team traveled to the site and published their analysis in the journal Nature in 1998, drawing global attention to what they described as a Stonehenge in the Sahara. The calendar circle has 4 pairs of larger stones and a series of smaller stones. 2 of the pairs align to form a north-south line. The other 2 pairs form an east-west line and a line pointing to the summer solstice sunrise. This would have been important to the nomadic people of Nabta Playa because the summer solstice coincided precisely with the arrival of the monsoon rains, the rain that filled the lake, brought the grass, and made life possible in what is otherwise a killing desert. Getting that timing right was the difference between arriving with your cattle when there was water and arriving when there was none. Inside the circle are 6 central stones. University of Colorado astrophysicist Thomas Brophy proposed in 2005 that 3 of these central stones correspond to the position of the 3 stars of Orion's belt when at their lowest point in the sky, and another 3 match Orion's shoulder and head stars. Malville and a team of archaeoastronomers published follow-up research in African Sky in 2007, proposing that the broader stone alignments at Nabta Playa point toward Arcturus, toward Sirius, toward Alpha Centauri, and toward Alnilam in Orion's belt. Whatever the precise astronomical function, and researchers still debate the details, the physical evidence is unambiguous. A group of nomadic cattle herders in what is now the Egyptian desert erected a stone structure aligned to the sky roughly 7,000 years ago, 1,000 years before Stonehenge, and 2,000 years before Newgrange. Malville called it human beings' first attempt to make some serious connection with the heavens. And this was in the Sahara Desert, from people we had assumed were too scattered and too primitive for anything like this. If you are still with us, and this is landing the way it should, drop a comment from your city. We want to know where in the world this story is reaching. And subscribe if you value history that actually goes deep. It's how you support research like this. This script uses real peer-reviewed sources. Hockley and Gopher in the Cambridge Archaeological Journal, 2020. Schultz-Paulson's Neosea Project in Antiquity, 2025. Malville, Child, and Wendorf in Nature, 1998. And Glenn Dash's engineering analysis published in the Journal of Ancient Egyptian Architecture, 2017. Now back to the stone. Because the biggest example of prehistoric precision calculation sits on a plateau at the edge of the Sahara Desert, 60 kilometers southwest of modern Cairo, and it is the most precisely oriented large structure ever built in the ancient world. The Great Pyramid of Giza was constructed during the reign of Pharaoh Khufu between approximately 2,580 and 2,560 BCE. It is 138.5 meters tall. It contains approximately 2.3 million stone blocks, each weighing between 2 and 80 tons. Its base covers 5.3 hectares, and its 4 sides are aligned to the cardinal directions, north, south, east, west, with an accuracy that still makes engineers stare. Engineer and archaeologist Glenn Dash, who conducts work on the Giza Plateau with the Ancient Egypt Research Associates, published a detailed study in 2017 in the Journal of Ancient Egyptian Architecture. His finding, the sides of the Great Pyramid are aligned to the geographic cardinal directions. Not magnetic north, but true geographic north, with a deviation of only 3 minutes and 38 seconds of arc on average. That is less than 1/15 of 1 degree. The base is level across its entire 5.3 hectare surface to within 2 centimeters. 2 centimeters of variation over an area roughly 7.5 football fields wide. The pyramid's base is almost a perfect square, with the 4 sides deviating from perfect by less than 0.01%, according to surveys conducted by Egyptologist William Flinders Petrie in 1881 that have been confirmed by modern technology. Egyptologist Karen Spence of Cambridge University proposed in research published in Science in 2001 that the alignment may have been achieved by observing 2 circumpolar stars, Kochab and Mizar, and bisecting the arc between them as they rotated around the celestial pole. Dash's 2017 study tested a different method, using a vertical gnomon rod and tracking the shadow tip's arc during the equinox, then connecting the endpoints of the arc to establish true east-west with extraordinary accuracy. He demonstrated that this simple method, requiring only a clear day and a straight rod, can reproduce both the accuracy and the specific type of slight error, a counterclockwise rotation, that all three of the largest pyramids share, including the Great Pyramid at Giza, the Pyramid of Khafre at Giza, and the Red Pyramid at Dashur. All three lean slightly counterclockwise. The same technique used at all three sites, producing the same tiny systematic error at all three sites. There is also the question of what mathematical principles were embedded in the pyramid's proportions. The ratio of the Great Pyramid's base perimeter to its height, 1,760 cubits of perimeter over 280 cubits of height, equals 2 times pi to an accuracy of better than 0.05%. That is an extraordinarily precise approximation. The Rind Mathematical Papyrus, an Egyptian document from around 1650 BCE but believed to copy earlier texts, shows that the Egyptians approximated pi as roughly 3.16. The debate in Egyptology is whether pi was encoded intentionally or whether it emerged from the practical use of the seked, a measuring tool expressing the horizontal displacement per cubit of vertical rise. Egyptologist Professor Werner wrote, "We can conclude that although the ancient Egyptians could not precisely define the value of pi, in practice they used it. The precision in the physical structure is not contested. 2.3 million stones placed over approximately 20 years, leveled to within 2 centimeters, oriented to within 4 minutes of arc to true north, with no magnetic compass, no GPS, no digital instruments of any kind. And there are the internal shafts. 2 narrow rectangular channels extend from the king's chamber deep inside the pyramid, each about 20 centimeters wide. The southern shaft descends at an angle of 45 degrees and appears to point toward where the star Alnitak in Orion's belt would have appeared around 2500 BCE. The northern shaft points toward where Thuban, the pole star at the time the pyramid was built, would have been. Whether these were designed as spiritual pathways, ventilation channels, or star alignment shafts is debated, but their angles are not random. They were calculated. Now, slow down for a moment, because none of these sites, Göbekli Tepe, Nabta Playa, Newgrange, Karnak, Giza, knew about each other. Southeastern Turkey, the Egyptian Sahara, Ireland, Brittany, Egypt. These were different cultures, different centuries, often separated by thousands of kilometers and thousands of years. And they all converged on the same behavior, using precise measurement, geometric calculation, and astronomical observation to build structures aligned to the sky with an accuracy that modern engineers confirm is real. This convergence did not come from some single school of knowledge passing between them. It came from human beings observing the same sky, developing the same need to track it, and applying the same capacity for precise spatial reasoning that we still have today. The math was in the people before the word mathematics existed. Alexander Thom, a professor of engineering at Oxford University, who surveyed over 400 megalithic sites across Britain, Ireland, and Brittany between the 1950s and the 1980s, identified a unit of measurement he called the megalithic yard. After measuring monuments from Orkney down to Brittany, he concluded that builders across all of these sites were using a standard unit of approximately 0.83 meters, or 2.72 imperial feet, with a precision he calculated at plus or minus 0.002 feet. He published his first paper in the Journal of the Royal Statistical Society in 1955 and continued refining his measurements for decades, publishing full-length books in 1967, 1971, and 1978. His final estimate for the megalithic yard was 2.722 feet, plus or minus 0.002, maintained, he argued, with unvarying precision across 1,000 years of building from approximately 2,500 to 1,500 BCE. Thom also proposed that the builders understood Pythagorean triangles, specifically the 3-5-4 right triangle, and used them to generate precise right angles in their constructions. The book Megalith, edited by John Martineau, extended this argument in 2017 to show that Pythagorean geometry was being applied at Stonehenge and other British circles roughly 2,000 years before Pythagoras formalized the theorem in ancient Greece. Stonehenge itself offers the most studied case. The monument sits at a latitude of 51 degrees 11 minutes north, a specific latitude that is baked into its design. The alignment of the monument to the summer solstice sunrise and winter solstice sunset cannot be coincidental, because that alignment only works precisely at this latitude. Move Stonehenge 200 kilometers north or south, and the alignment breaks. The builders chose this specific spot on this specific hill in what is now Wiltshire, England, and oriented their construction so that on the longest day of the year, the sun rises directly over the heel stone and its first rays flood the center of the monument between the horseshoe arrangement of trilithons. American astronomer Gerald Hawkins ran every possible alignment between 165 significant Stonehenge features through a Harvard-Smithsonian IBM computer in 1963, and found not one or two, but dozens of significant solar and lunar alignments. He published his findings in Nature and later in the book Stonehenge Decoded. The Sarsen Circle, the ring of massive standing stones we associate with Stonehenge today, forms a circle 97.5 feet across in which every upright is, on average, less than 3 inches out of position. The 4 station stones form a perfect rectangle whose long axis is around 300 feet in length and whose diagonal aligns with the summer solstice sunrise. The 56 Aubrey holes, chalk-filled pits arranged in a circle just inside the earthwork bank, have been proposed as a mechanism for tracking the 18.61-year cycle of the moon, which governs when eclipses occur. By moving a marker 3 holes forward per year around the circle of 56, a lunar astronomer at Stonehenge could keep track of the node cycle and predict eclipses in advance. The construction of Stonehenge spans from approximately 3100 BCE for the earliest earthwork phase through roughly 1500 BCE for the final stone arrangements, an engineering and astronomical project maintained across 1,600 years. The bluestones, the smaller inner stones at Stonehenge, were quarried in the Prehistoric Hills of Wales, approximately 240 kilometers from the site. Massive sarsen stones came from Marlborough Downs, about 25 kilometers away. Each sarsen weighs between 25 and 30 tons. Moving them without wheels, without metal tools, and without engines required the kind of coordinated logistical planning that we associate with large organizations, not with scattered groups of farmers. And once they arrived, they were shaped to exact tolerances and fitted together with tongue and groove joints carved into the stone. These were not people stumbling toward mathematics. These were people who had fully operational spatial reasoning, who had developed measurement standards, who shared those standards across large geographic areas, who tracked celestial cycles over decades and centuries of patient observation, and who translated all of that into stone so that it would survive exactly as long as stone survives, which is long enough to still be standing in 2026 while we are making videos about them. It is worth sitting with the geometry of Newgrange one more time, because of what a 2024 study of ancient DNA found inside the chamber itself. Researchers analyzed the genome of a man whose bones were discovered in the most prominent recess of the Newgrange chamber, the most sacred position in the most sacred structure of Neolithic Ireland. He was the product of first-degree incest. His parents were either siblings or a parent and a child. In small-scale societies, incest taboos are nearly universal. The fact that this man was born of close relatives and was placed in the most honored position in the tomb strongly suggests he belonged to a ruling dynastic family so powerful it was exempt from normal social rules, comparable to the god kings of ancient Egypt or the royal lineages of the Inca, who married within the royal family to keep divine bloodlines pure. So at Newgrange in 3200 BCE, there was not just sophisticated astronomical engineering. There was a ruling class powerful enough to organize the construction of a 200,000-ton monument and to break the deepest social taboos while doing it. The builders were not primitive, they were organized, they were specialists, and they were doing mathematics under a different name, the name of survival, the name of ritual, the name of the sky. Here is the late detail that rewrites what you just heard. In June 2025, Schultz-Paulson's NEOCEA team discovered something while excavating Le Plasker in Ploughornell, Brittany, ahead of the construction of a 7,000 square meter business park. Beneath the megalithic layers at Le Plasker, beneath the stone alignments that radiocarbon dating placed at 4,600 to 4,300 BCE, they found a monumental tomb. It dated to approximately 4,720 BCE, and it was built directly on top of the remains of a Mesolithic hunter-gatherer hut. The tomb was the beginning, the alignments came after, which means the people who laid out 10 kilometers of geometrically precise stone rows in Brittany were building on a foundation laid by people who had not yet made the transition from hunting to farming. The precision did not begin with civilization. The precision was there in the people who were barely settled. It was there at Nabta Playa before the pyramids. It was there at Göbekli Tepe before agriculture. It was there at the bottom of Karnak before the rows began. We did not get precise when we got civilized. We were always precise. The stone is the proof. It is still standing. Let us go deeper into Göbekli Tepe, because the pillars themselves carry information that researchers are still decoding. The T-shaped limestone pillars, the oldest known megaliths in the world, are not plain. They are decorated. Abstract pictograms, carved animal reliefs, and anthropomorphic details appear across dozens of pillars. Some depict foxes, scorpions, vultures, lions, snakes, and wild boar carved in high relief. The 2 taller central pillars in each enclosure, the ones that stand facing each other at the center of every circular structure, appear to represent human figures. They have carved arms at their sides, hands reaching toward a belt at the waist, and what appear to be items of clothing. They are not just structural supports. They are representations of beings, possibly ancestors, possibly gods, possibly both. Klaus Schmidt, who excavated the site from 1995 until his death in 2014, calculated that transporting and erecting the heaviest pillars would have required hundreds of people. One pillar, still partially attached to its quarry bed about 100 meters from the hilltop, is estimated to weigh approximately 50 tons. It was never finished and never raised. It sits there today as direct physical evidence of the construction process. To cut it, workers used flint hand tools, pointed stone instruments chipped to a sharp edge. To free it from the bedrock, they chipped a trench around it on 3 sides. The scale of the labor required to do this across dozens of pillars, and then to move those pillars and raise them to vertical positions, points toward something that Göbekli Tepe researcher Jens Notroff of the German Archaeological Institute described as one of the most complex construction projects undertaken before the dawn of agriculture. The German Archaeological Institute has been coordinating ongoing excavations at the site since Schmidt's death, with Istanbul University and the Şanlıurfa Museum. The geometric insight Hockley and Gopher revealed in 2020 adds another layer. Their algorithm found that the centers of enclosures A, B, and C are connected by 2 legs of an equilateral triangle and a line that bisects one of those legs at a right angle. This is a specific geometric construction, a particular spatial arrangement that requires understanding of spatial proportions and the ability to lay out reference points precisely in a landscape. Hockley, in the paper, described the pattern as reflecting spatial and symbolic hierarchies. These were not 3 circles placed randomly near each other and later found to accidentally align. They were laid out as a unified whole by someone who had a master plan in their head or scratched on something that has not survived before the first pillar was moved. According to Professor Gopher, the project may have involved thousands of workers, and the level of organization required would be equatable with much later sedentary groups of farmers. But these were hunter-gatherers, still nomadic, still moving with the seasons to follow prey and wild plants, and yet organizing construction at this scale with this geometric precision. This matters because the standard model of human development placed complex cognition, geometric planning, and coordinated large-scale construction after the agricultural revolution, after people settled down, grew surplus food, and had time to specialize. Göbekli Tepe upends that timeline by at least 3,000 years. The geometry came first, the math came first, and then agriculture might have followed. Some researchers now propose, controversially, that the need to feed the massive workforce constructing ceremonial sites like Göbekli Tepe may have actually been one of the drivers pushing people toward farming in the first place. Grow grain to feed the builders. The builders came before the grain. Back to Karnak. Because the recent 2025 dating of the plasker did something else remarkable. It confirmed that the stone lines were oriented consistently across multiple construction phases spanning hundreds of years. The north-northwest to south-southeast orientation was maintained across generations of builders who were not the same people, who lived in different centuries, and who presumably inherited the project from ancestors they likely could not communicate with through any written record. How do you maintain a geometric orientation for hundreds of years without writing? You encode it physically. You train the next builders in person. You pass down the measurement standards and the reference directions as embodied knowledge, the same way a master craftsman teaches an apprentice by showing, not by writing. At the alignments du Menec, the largest single field among the Karnak alignments, with approximately 1,100 stones in 11 parallel rows over 1 kilometer, the rows begin with smaller stones at the eastern end, and the stones increase in size toward the western end, where the largest reach 4 meters in height. This is not structural necessity. A taller stone at one end serves no engineering function that requires it to be taller than the stones at the other end. This is design. This is intentional variation in scale, planned along the length of a kilometer-long geometric installation. There is also a partial stone circle, a cromlech, at the western end of the Le Menec alignment. Circles terminating long alignments appear at several points across the Karnak complex, suggesting that the rows were not randomly extended, but were conceived as complete compositions with specific endpoints. The Likermario alignment, just east of Le Menec, contains approximately 1,030 megaliths in 10 rows. From a stone observation tower called the Moulin de Kermaux, positioned midway along the alignment, you can look out over the rows from above and understand the scale. They stretch to the horizon in both directions. These rows were not built by a small group over a few years. Radiocarbon evidence confirms construction over multiple centuries. That means multiple generations of people, across multiple lifetimes, maintained the project, knew what it was for, and kept building in the same direction. Now, let us look at what practical tools were used to achieve this level of precision. Because the mystery is not whether it was done, the stones are proof it was done. The mystery is how. For Stonehenge, Alexander Thom's surveys across more than 400 sites concluded that the builders were using the megalithic yard as a standard unit with a precision of approximately 0.002 feet. This level of consistency across 400 plus sites in Britain, Ireland, and Brittany implies either a central authority disseminating a standard measurement or a system of transferable physical standards, like a measuring rod of a specific length, that builders carried, copied, and passed on. Tom wrote in 1955 in the Journal of the Royal Statistical Society that megalithic people were able to mark stones to within a few thousandths of an inch. That paper started a controversy that ran for decades, with archaeologists like Richard Atkinson pushing back on the idea that Neolithic people operated with this kind of precision. But Tom's surveys of over 400 actual sites are a body of physical measurement data that cannot be dismissed without explaining why the numbers line up the way they do. For the Great Pyramid of Giza, Glenn Dash's 2017 experiment showed that an equinoctial gnomon shadow can achieve the cardinal direction alignment seen at Giza using only a vertical rod, a flat surface, and a clear sunny day. The Egyptians would have been able to determine the equinox by counting 91 days forward from the summer solstice, trackable without writing by counting days on fingers or notches on wood. Once the equinox was established, the shadow from a vertical rod at solar noon traces east and west, and its arc through the day establishes the north-south axis by connecting the morning and afternoon shadow endpoints. The slightly counterclockwise error that all three of the largest Pyramid-age pyramids share, noted by Dash in his paper, appears when the equinox is not precisely on the correct day, which would happen if the day count method was off by 1 or 2 days. All three pyramids with the same small systematic error of the same type and direction. Same method, same tiny mistake. 3 times. What did it mean to these builders to get this precise? For the people at Nabta Playa, precision was life. If the stone circle told you the summer solstice was approaching, you knew the monsoon rains were about to arrive. You knew to move your cattle to the lake bed. You knew when water was coming. Getting that moment wrong by even a few weeks could mean arriving at a dry lake with a herd of cattle and no water source for hundreds of kilometers in any direction. The astronomical precision was not abstract. It was tied directly to survival, to food, to water, to life. For the builders at Newgrange, the 17 minutes of winter solstice light entering the chamber may have represented the rebirth of the sun, the moment when the longest night of the year was over and the sun began its return journey. Irish mythology preserved the memory of this event in the story of the god Dagda, who made the sun stand still for 9 months while his partner Boann was pregnant, so their child was born in only 1 day. John Carey, a scholar of Irish mythology, argues that the tales associated with Brúna Boina, Newgrange's mythological name, are the only Irish legends where a sacred site is connected to the control of time. That memory was so strong, it survived from 3200 BCE through to the medieval manuscripts that recorded it, several thousand years later, as religious story. For the builders at Göbekli Tepe, the geometry of the enclosures may have represented a cosmology, the circular structures as the world, the T-shaped pillars as ancestors or divine figures, the animal carvings as a symbolic mapping of the universe onto stone. Whatever the meaning, the precision was the point. These were not sketches. They were not approximations. They were exact constructions meant to stand forever and to carry meaning in every dimension they occupied. What is the coldest number in all of this? Here is one. At Newgrange, the DNA study published in 2024 confirmed that the man placed in the most sacred position in the most sacred room of the most precisely engineered monument in prehistoric Ireland was the son of siblings or parent and child. Ireland's Neolithic builders calculated the winter solstice to within half a degree of the sun's disk and built a monument that has stayed watertight for 5,200 years. And the person at the center of it all, the body in the innermost chamber, was someone whose family broke the deepest human social taboo to maintain a bloodline of power. Precision in stone, power in bone, both built to last. This is where they left it.